Okay, in this video I want to talk about the square of opposition, and I needed to establish the names first of the categorical propositions, the A, E, I, and O that you see behind me, well placed. Uh, those really form the corners of the square of opposition. So we're going to develop that on the screen, on the board in a second here. But the idea behind the term, all right, opposition is not that they're opposed to each other as I would oppose a certain movement or view that I was against. The term is really a placing against, or a relationship that they have to each other. All right. So let's take a look, and the name should become clearer as we see these relationships unfold. Okay. You have the A and the I on one side, so the affirmo part over here, the affirmative part here, the negative part on this side. All right. And then you have the universals at top and the particulars at the bottom. All right. Now, what we do is we go ahead and say we have ways these can be related to each other or positioned in relation to each other. Okay, so that's we're getting closer to the actual root position idea. So you have the A and the E, the A and the I, the A and the O, the E and the I, the E and the O, that sort of stuff. Okay, now it makes sense quickly to talk about the A and the I, the relationship to each other. This is going to be like all A is B, right? This is sum A is B. Now remember, this is kind of silly because we got the A here and the A here, but I should maybe saying all X is Y or something like that. You know, these are not the same A's. Okay, this is just any category. This is the universal affirmative. Now over here we have no A is B, and here we have some A is not B, right? So we have the universal negative, the particular negative. Now, the O and the E stand in relation to each other in what's called a subaltern position, and the I and the O. Okay, so this is called the subaltern. I'm going to have to write it like this. Maybe subalternate, because this is really called the subaltern. It's the subaltern to A. And the idea is, and there is actually some debate about this, but this is what we have to assume when we're working at this in first blush like this, the first approach. If A is true, then I is also true. That's the relationship between the subaltern. So if all dogs are things that have fleas, then there is some dogs are things that have fleas. That holds too. Okay. Now this is subalternate. The subalternate relationship, and this is just subaltern. And again, the idea is it's you know what? I need to draw the arrow this way, right? Because if this is true, then the idea is this is also going to hold. I should say hold. That's better. If this holds, then this holds. So if no dogs are fish, then there is some dogs that are not fish. Okay? So there you have it. So no dogs are opera singers. That automatically then we can also say that the statement some dogs are not opera singers also holds or obtains. Now what we cannot say, we can't let it go backwards. We can't say since some dogs are not opera singers, therefore no dogs are opera singers. We can't do that. Okay, but anyway, E stands to O, or O is under E in a subalternate position, and I is under A in a subalternate position. Now, what do we call these? These are contraries. Okay? So A is contrary to E, and E is contrary to A. And what is the situation here? Well, the situation about contraries, okay, is this. Both can be false at the same time. But not true at same time. So the interesting thing about contraries is, in fact, I'm just going to repeat what I wrote. They both can be true. They both can be false at the same time, but they can't be true at the same time. Okay. So, given that idea, if one of them is true, and you know that one is true, does it make the other one false? Yes, because they can't both be true at the same time. But if one of them is false, does it make the other one true? No, because they both can be false at the same time. Okay, so we know that they can't both be true at the same time, but the thing is, they can both be false. So it gets a little tricky. Let's go down over here. Contraries, these are called subcontraries. So A is a subcontrary to O, and O is a subcontrary to T. Excuse me, I is a subcontrary to O, and O is a subcontrary to I. And the interesting thing about this is that both can be, let's see, both can be false at the same time. So down here, both can be true at same time, but not false at the same time. Okay. So some A is B. We go some dogs are pets. Okay. Some A is not B. Some dogs are not pets. Do you see how they both can be true at the same time? But they can't both be false at the same time. If some dogs are pets, if that is false, then some dogs are not pets has to be true. So they can't be false at the same time. But they can certainly be true at the same time. Okay, so that's the relationship subcontraries have to each other. Now what about this? The A is related to the O, and the I is related to the E in what's known as contradictories. Okay, so contradictories. I is contradictory to E, and A is contradictory to O. The thing about contradictories is that, and this has to be the case, if this one has to be true and one has to be false. It has to be that way. Or I should rather say one obtains and one doesn't. That's what it has to be. So, now I'm using the word false here and true, so I'm going to go ahead and stay with that. One has to be true and the other has to be false. Now, one and the other, you got to figure out which one is which, but as soon as you figure out which one is true, you know automatically the other one is false. The same thing with I. If I is true, E has to be false. If E is true, I has to be false. So the interesting thing about contradictions is that they always come in pairs. The true contradictory, argument is going to have two statements involved. And the interesting thing is, truth has to be there along with falsity. Now, let's take a look. Some dogs are pets. No dogs are pets. If this is true, this has to be false. Some dogs are pets. If no dogs are pets, then it's false that some dogs are pets. If at least one dog is a pet, if that is true, then the statement no dogs are pet is false. So they bounce off each other. All right. And in fact, when you can practice this properly, this rule about contradictions, the fact that one of them has to be true and the other has to be false, is very useful. And perhaps we'll have a chance to practice with that. But this is as far as I need to go as far as giving you the information of the square of opposition. The one thing I do want to point out here is that there's something involved here too, and it's called immediate inference. Okay, an immediate inference is that from one statement you can draw another statement as a conclusion, as long as you operate correctly in the movements of the square of opposition. So, in other words, from the statement, all A is B, automatically you can draw the immediate inference that some A is B. Okay? From the statement, some A is B, you can automatically draw the immediate inference that no A is B is false. Okay? So, when I say some chefs are not music lovers, I automatically know that the statement all chefs are music lovers is false. It's immediate inference. Okay, so sometimes you'll hear that term, or you'll hear an argument, advocated for in terms of immediate inference. That's what the people are talking about. They're talking about the square of opposition. And if E is true, then I has to be false, that sort of thing. If E is true, then O is false. That's all immediate inference. So it's good to know that term and to know that it relates to statements and their relationship to other statements of the I, E, O, and A form. Okay. Now notice that all of these have to do with, let's pick something. Let's say all dogs are pets. So then all of these statements have to do with dogs and pets. All dogs are pets, no dogs are pets, some dogs are not pets. And based on those formations, if some dogs are pets, I know automatically that the statement no dogs are pets is false. So it's really that simple. Immediate inference is actually kind of self-evident once you understand the square of opposition.